Hey, Chad, thanks for joining us today as we talk about the exciting subject of linear algebra. For those you don't know, Chad went to Lee and graduated just about almost 3 years ago now. But can you start off, Chad, and tell us a bit about yourself?
Yeah, thanks for having me, Dr. Moy. Thank you for the invite as we get to uh, discuss this wonderful world of linear algebra. Um, my name is Chad. I went to Lee, graduated in 2022. My degree was in mathematics with a pre-engineering emphasis, um, which for me essentially meant grad school or bust. So I decided to pursue grad school. And so I attend the University of Tennessee, Knoxville. I'm a third year PhD student in the Department of Industrial and Systems Engineering. I am looking to possibly graduate in spring 26, but it could be any range between spring 26, spring 27. And my research more so focuses on things regarding optimization. Love doing mathematical modeling, and really my everyday workflow, what I enjoy working on is converting logic into math into code. And any project that follows that general stream, I'm like, hey, sign me up. That's what we like to do. So that's a little bit of background on me.
Yeah. What were you involved in during your time at Lee? Like, where'd you spend your time when you weren't studying?
When I was not in the basement of the mathematics offices of the professors, being a good student, I spent most of my time doing undergrad crew at Lee. I say undergrad, it's just crew at Lee. Um, but so yeah, I was part of that for um, the first 3 years of my time at Lee, and I was on leadership with crew for 2 of those years. I also was a peer leader for 2 years, and I'm seeing the last round of students that I was their peer leader for coming into their final semester at Lee as they're getting ready to graduate. You know, feeling a bit of a proud peer leader moment. Um, so yeah, did that for 2 years. Um, and oh, I was also part of the McNair Scholar Society. So they helped to be able to prepare me a lot for grad school, and I highly recommend being able to get involved with them if you have any grad school aspirations. They were integral into getting me into grad school. So those are the clubs that I more so spend my time with. So yeah.
Well, thank you for, connecting your experience a bit to the students here. Uh, my first question after the initial one is, what was your experience with linear algebra? Well, I know you had a unique semester, but what was your initial impression of the subject?
Yeah, so the semester that I had it for everybody out there was spring 2020. So we were very much interrupted by COVID. So it was definitely a unique experience having the first half of it being on campus and then the second half being virtual. Dr. Moy, props to him for making that work as well as he could. He did a great job of delivering material in that time. So props to you. Um, but yeah, the class was, I would say that is probably the most unique math class that I ended up taking at Lee. I think that it would have probably felt, because I never took an analysis class, I feel like that probably would have been one of the things that was most closely related to linear algebra as far as the feel of the class. But it's a very different way of thinking. There were a lot of different concepts that whenever they're initially presented to you, you feel like they are, just very complicated and complex and like, oh, how do I wrap my mind around this? But whenever you break things down into their simplest form, you really start to get this picture of how all of these different ideas end up working together to be able to just form this very cohesive and, dare I say, straightforward narrative of how linear algebra actually works. So it can be daunting in the beginning as you're learning all of these different definitions and you're learning all these different things to be able to equip you to be able to solve problems. But then whenever you get to see actual applications of linear algebra, you realize, oh, this is not just complete theory that I would never have to use. This has very practical applications um, that you just have to spend the time to wrap your mind around.
Yeah. Well, on that topic, what are a few areas, or maybe one main area, depending on how much time you have, that you've seen linear algebra arise, either in later classes that you took or in your own research and time as a grad student?
Yeah, linear algebra is absolutely littered throughout all of optimization theory. It's, I was thinking about some of the earliest theories, like the simplex algorithm that was developed. I think it was developed in like the 1950s or so. And the simplex algorithm is very much tied to linear algebra, where you are forming a basis with certain variables and then interchanging some of those variables to change your basis to be able to um, find an optimal solution for a linear program that you're working with. And that was optimization theory back in the 1950s. So we have 75 years of development that have gone on top of that, but definitely the root of um, all the mathematical models that we end up working with and running. At the end of the day, it's really just different variations of matrix multiplication, essentially. Um, but you do have a lot of programs that you write that are, tens of thousands of variables, hundreds of thousands of constraints, and stuff like that. So you can't really write it out all on paper, but certainly whenever you look at shorthand versions of mathematical models, you see so many different things like the transpose of matrices and things of that nature. So it pops up a ton in my research.
And for our viewers at home, could you give like a short description of like what is linear programming and why do you care about it?
Yeah, so linear programming, if I can sum it up very succinctly, is um, let's say that you are trying to solve a certain problem, and there are a lot of different solutions that can work for the problem. So let's say you have like a number line, for example, and for the problem, any number between 1 and 10 is an adequate solution, but what you're trying to find is the best value in there for whatever you're optimizing. And so what a linear program does is, since that space that you are optimizing over is continuous, um, you're you're basically exploring some of the extreme points of your program or extreme points of your feasible region. So our feasible region in this case is numbers 1 to 10, and your program is solving, and maybe if you're maximizing, then you find that when you have a value of 6, that results in the greatest number for your function, and you're like, okay, so the optimal solution, the number that maximizes what I'm solving here, is 6. So the linear program is essentially exploring a continuous feasible region that's also convex. We don't have to go into details on that if we don't need to, but essentially just think about like that continuous line or a ball. Like, I'm trying to make a ball here. So yeah,
It's like your favorite topic from calculus, it's like optimization problems on steroids.
it really is. And I'm like, hey, I really like that.
uh, what do you think, given your experiences, are things that you found to be the most important takeaways from your first linear algebra class?
I think, okay, this is a very practical one. Dr. Moy is going to appreciate this. Introduction to LaTeX. I don't know if Dr. Moy still uses LaTeX or not.
Yes, little.
But yes, if Dr. Moy ever makes you do an assignment in LaTeX, it at the time, I promise you, I felt the same way. You'll feel like, wow, I'm never going to use this again. And now LaTeX is like the only thing that I use, and I write all my papers in LaTeX. So
Yeah.
give it a chance, give it a puncher shot. The way that I did not in that class. And I'm sure from this video, Dr. Moy will probably pull up one of my old assignments for you to see how bad my LaTeX skills were.
I would love to pull up your first assignment, show everyone somewhere in the archive. Thank you, computers. Um, Last but not least, what advice or words of wisdom do you have for current linear algebra students?
The biggest piece of advice, well, I guess it would really be two. Number one is don't like confusion is okay. Like there's going to be, if you're like me, it's a very different way of thinking. It's a much more abstract way to think about things. And it can be difficult to kind of get your mind to wrap around it. You know, whenever you're taking a calculus class, for example, you're able to write out a function. You're able to see how a derivative actually looks as a tangent line to a function. But with linear algebra, there's a lot more very abstract thinking. I mean, you know, you can very quickly in linear algebra get up into like trying to visualize something in 8 dimensions. And it's like, how does that work? I don't know, but it does. So it's okay to be confused. Confusion does not mean failure. Confusion only means that you're taking the next step into understanding. So that would be one piece of advice. And the second piece of advice I would have is go to Dr. Moy's office hours, or really any of the professors. Like if you have a professor that you have a good relationship with, like definitely go talk to people, um, because you know what Dr. Gladden, she always says math and community, right? So you know it's always going to be better for you to be able to talk to somebody about your questions. And um, there really is no such thing as a bad question. You know, it's like definitely ask questions and go to Dr. Moy's office hours, and hopefully he'll help you more than he helped me. I say that as a joke. Dr. Moy was very helpful in pushing me as a student to attain a better understanding.
Well, on that note, Chad, thank you for joining us. Feel free to come back around anytime. Uh, and for at least a few more months, visit your last remaining peer leading students from your gateway. But do feel free to come back anytime. Thanks so much, Chad.
Thank you, Dr. Moy.